my recording on time today. So today we're going to just go over the rest of our notes. We're going to review all the assignments that are due for this week. And we're going to go over this warm up. Of course, it's on here on the PowerPoint side. But before we get into any of that, of course, we have to make some announcements for this week. I didn't get a chance to make them on Monday because I didn't have them, but I do have the announcements now. Of course, the first reminder is that fall break is next week, so there will be no live classes next week. You still have your classes today, tomorrow, and Friday, but next week there are no live classes. This will give you a great chance to get caught up on all of your work. Make sure you ask your teachers your questions about what work is still outstanding to get that work in. And enjoy your time off as well if you can, right? It's supposed to be a DCPS break as well, so that's why we're also on break. Announcements for this week in general. Make sure that if you have any problems or questions about anything, technology schedule classes, make sure you call this number that I'm going to put into the chat. And also say out loud for the recording, 202-289-6623, extension 128. If you leave your name, your phone number, and a reason for your call, they'll hopefully get back to you within 24 hours. That includes next week, because next week only everybody will be on staff, just not available for classes, okay? For this Wellness Wednesday, because today is Wednesday, the topic is domestic violence awareness, and there's a presentation that's going to be posted to the homeroom by one of our student support specialists, Ayaba. And so that's going to be in the homeroom if you want to take a look at that presentation and that video. Remember, if you need a tutor, please provide me with your name and the subject, and we can get you a tutor. Always check your AOH emails. That's very important. Check your AOH emails regularly because that's where all the communications will be sent. And the winners for round 2 for trivia include our own Videra Clark. Woohoo! So Videra is going to get a $25 Visa gift card this week. And also Ashley Short is our other winner. I believe the trivia for this week has been posted in the homeroom. I'm not really sure. I don't look. So if you want to check out that, you can try to get a $25 Visa gift card by going to the homeroom and answering those questions. Okay, so let's take a look at this warm up here now that all of my announcements are over. So we have the numbers 3, 1.7, -14, and -1/2. All right, so is 3 a whole number, an integer, a rational number? What is 3? How would we describe 3? Is it all of those things, none of those things, one of those things? What is 3? Is it a whole number?
It's a whole number.
It's a whole number, okay?
And it's a rational number.
Okay. All right. Thank you, Ebony. I got it. All right. Okay. I see rational as well. I see that Toya said all. Okay. I definitely heard it's a whole number. I'm going to put that in. It is most definitely a whole number. 3 is one of our counting numbers. So yes, it is a whole number. Is 3 also an integer? Yes, 3 is also an integer. Is it also a rational number? Yes, it's also a rational number. Any number that can be written as a fraction is a rational number, and all of your whole numbers can be written as a rational number just by putting a 1 under them. So 3 is all of these things. What about 1.7? Whole number, integer, rational number. What is 1.7? An integer. That's what I see from Lucretia. Anybody else? What do we think? Integer, Victoria as well. Integer from Videra, okay. Okay, so 1.7 is actually not an integer. An integer is all of your whole numbers and all of your counting numbers, including 0, that are also negative. But it is not any number that is a decimal or a fraction. Those are not integers. So 1.7 would be a rational number, right? And that's the only category that 1.7 belongs to. It is part of a whole number with the 0.7, but it is not a whole number. It can't be that, definitely not that. And it's not an integer just by virtue of having this decimal. With a decimal, it is not an integer.
I have a
Right.
question. How come it's not a whole number? Is it because it's the 0.7?
Correct, right? A whole number cannot have any part of a number. It can only be a whole, right?
Okay.
So 1.7 or 1 7/10 or anything with a fraction or a decimal can never be a whole number.
Okay.
A whole number by definition is a whole number. It's a complete and total number, no parts of a number at all. All right, what about -14? Whole number, integer, rational number. I see some comments coming through.
The whole number, right? Is it a whole number?
-14, is it a whole number? You tell me.
Maybe.
Maybe? Is it a whole number? What's the definition of a whole number? Y'all thought you could just put it in the past. You're like, oh, I learned that a while back. It's fine. I don't need to remember that. Mr. G is going to bring it back up. It is definitely an integer. I see people in the comments have said integer. Yes, it is definitely an integer. We at least know for sure that it's an integer. Good work with that. It is in fact an integer. Toya says it's all. Is it all? It is not all, but it is definitely an integer. No, sorry, I have to go back. My slideshow here. Is it all? It's not all, but it is definitely an integer. So let's mark it as integer. What is it not? It is not one of these other two things. It is not at least one of these other two things. Is it not a whole number or is it not a rational number? Y'all are so quiet for a Wednesday morning. What happened? It's not rational. -14 is a rational number. Remember, rational numbers include anything that comes before it, which includes integers, whole numbers, and natural numbers. Because a rational number is just any number that can be written as a ratio. And I can write this as a ratio. So -14 is a rational number, but it is not a whole number. Again, whole numbers cannot be negative. When they become negative, we call them integers. All right, and the last one, -1/2. Is it a whole number? Is it an integer? Is it a rational number? Integer and rational. Integer. Rational. All right, keep guessing, y'all. Keep guessing. I want to see integer. Integer, integer. Okay, so it's not a whole number is what you guys are saying to me. I don't see anybody saying whole number, so it's not a whole number. That is correct, it is not a whole number, okay? But it is only one of these other two things. So is it an integer or a rational number?
Integer.
It's not an integer, it's a rational number. It's a fraction. This is the definition of a rational number. It's a part of a whole. It's a half, right? A half is a rational number. It's a fraction. Any fractions or decimals automatically are rational numbers, okay? You can only be considered an integer if you are a whole number that is negative or positive. Once you have a ratio, you are not an integer anymore, right? Once you have a part of a whole, you're no longer an integer, you're just a rational number, okay? So rational numbers are the most inclusive. Almost everything can be a rational number. You can only be an integer if you are a negative or positive whole number, okay? And you can only be a whole number if you are a positive number, a positive counting number, okay? That's your basic definitions of what those numbers are. Remember, this is week 1 stuff. So if you have to review it, those notes are there. Go back and grab your notes, take a look at them. You have a break, a great time to review, right? Just because it's week 4 doesn't mean we can forget it, right? We still have to remember these things and to think about these things because you have to be able to apply it later, right? You can't just apply it for week 1 and be like, great, I learned it in week 1. You have to try to make sure you can retain that information when you're testing because you have to apply it during the test, okay? So go back, do your rational numbers, your integers, your whole numbers, and what those differences are. Remember, rational numbers are the most inclusive. They're the biggest group, okay? Any number that is a part of a whole is a rational number. You can only have integers become smaller. Integers are only whole numbers that are negative or positive. And then whole numbers, the smaller group, are only your positive counting numbers. Okay. We're going to go back to our notes now. We're going to finish up our notes. I'm going to go back to our notes page in Schoology, your week 4 folder. You're comparing rational numbers notes. That's what you guys should have open. We're going to switch to that so that we can do that together, finish those up together. So in your courses, one second, I'm logged out. Okay, there we go. Back inside my courses. Make sure you're in Math Skills 4 with Mr. G, week 4. And you're opening up, you're comparing rational numbers notes, right? This is the recording from Monday. This is the wrong thing. I opened up the lesson videos and not notes. Okay, comparing rational numbers notes. What? Schoology messing with me this morning. Okay, there we go. And you've opened the assignment in Kami, which I've actually already done, so I didn't need to do that, but I did it anyway. Just refresh the page. Schoology actually is working. It's just being a pain. Just refresh. It should be fine. I refreshed my page and it's back. It gave me that same message, but then it came right back. Okay, so on Monday, where we left off was comparing this decimal and this fraction, right? So we have the decimal 0.25 and the fraction 6/10. And to compare them, we turned them both into fractions, all right, to compare them. And we figured out that 0.25 is smaller than 6/10. What we're going to do today is we're going to review this one again, but by turning them both into decimals and comparing them. And then we're going to move on to the other examples. Okay. So in this one, we're going to turn 6/10 into a decimal. How do I turn 6/10 into a decimal? What do I need to do that? How do I turn that into a decimal? Who remembers?
Divide the to be honest, I don't know if it's the numerator to the denominator or the denominator into the numerator.
All right.
I know
So
it's
you're
one of those.
So basically, it's just so a fraction always tells you the same thing. You're just going to follow what the fraction says, right? It's 6 divided by 10. You read it from the top to the bottom, 6 divided by 10, right? So you're dividing the numerator by the denominator, 6 divided by 10. So that means the 10 is going to go on the outside of our long division box. And the 6 is going to go on the inside of our long division box. I cannot divide 6 by 10. So what do?
So basically, it'll be zero. You have to put 0 point.
Add a 0.
Yeah, to add a decimal.
Yep.
And then a 0. So now I can divide 60 by 10. What's 60 divided by 10?
6.
6. So that is going to give me 0.6. So that's my decimal, 0.6. So now I have 0.25, and I'm going to compare it to 0.6. Which one is bigger?
I'm gonna say
0.25. Oh,
0.25.
No, point,
Well,
point 6.
I think 0.6 because
because all you have to do is add a 0 and it'll make it 0.60.
Right? Remember, you're only comparing decimal place to decimal place. So if you need to cover it up with your hand or cover it up with something on the screen, like I can use my notebook here, I can cover up my screen, right? And I will only see the 2 and the 6. Which is bigger, 2 or 6? 6 is bigger. So it doesn't even matter that 5 is there, right? Only compare decimal place to decimal place. And when you do that, you will have 0.6 being the answer as to which one is bigger, right? Or, as Videra suggested, if that doesn't work, add a 0, right? To make it the same amount of digits after the decimal place. And then you can see that 60 is bigger than 25, okay? But whatever works, but 0.25 is less than 6/10. Okay, that's how we're going to compare those two rational numbers. All right, let's compare the next set of rational numbers in number 2 here, 8/10 and 0.45. Oh, 8/20, excuse me, and 0.45. So what are we going to do? You guys can choose. Are we going to make them both decimals or both fractions?
Decimals.
Okay, both decimals. That means we're going to divide this numerator by the denominator on this fraction here. So I have to do 20 into 8. I can't divide 8 by 20, right?
Mm-hmm.
So what do I got to do?
0.0.
I have to add a decimal and a 0. So now I can divide 80 by 20. What's 80 divided by 20? Or what's 8 divided by 2?
4.
Good. So I have 0.4 as my answers. Now I get to compare 0.4 to 0.45. Which one is bigger?
I would say 45. 45 the biggest.
Okay. Yeah, so 0.45 is bigger than 0.40, right? 40 cents or 45 cents? 45 cents is bigger.
Yeah,
So 8/20 is less than 0.45. Right, that's our answer for the second one. All right, and what about number 3 down here? So since we turned this last one into two decimals, this one we need to turn into a fraction. So we're going to keep the 5/10, but we have 0.09. How do we turn that into a fraction? 0.09.
9/100.
Very good. 0.09, the other way to name this is 9/100, right? Because this 9 is in the hundreds place. That also tells me how to turn it into a fraction by doing 9/100. So I have 9/100, right? And I'm going to compare it to 5/10. This 9/100, I don't have to simplify in any way because I can't simplify that. The only thing that goes into 9 is 3 and 9, and both 3 and 9 do not go into 100 evenly. So how do I compare these two fractions now that I have them? What do I do to compare them? Who remembers?
You,
Break them
the,
down.
I don't have
That's
to
not the proper word, but
Yeah, so yeah, you're suggesting to simplify them, and I could simplify this fraction on the left if I really wanted to. Yes, because this one can be simplified, but I don't have to do that necessarily, but I could simplify this one. What I was hoping for was just how do we compare them? When we're comparing two fractions, the way to compare two fractions is to
10 times the 9 and then the 100 times the 5.
oh, Mr. G, yes, you just taught us this.
right? To compare two fractions, you have to go from the bottom to the top in cross multiplication, always bottom to top, right? In a cross. So 10 times 9 gives me what?
90.
90. And 100 times 5 gives me what?
500.
500,
500.
right? And this is how I compare my fractions. By making sure I multiply from bottom to the top, I'm going to use the number on the left to tell me the value of the fraction on the left.
Yeah, so
And I'm going to use the number on the
basically
right
what
to tell me the value of the fraction on the right. So which one has a bigger value?
basically
500, right? So that means
Yes.
5/10 is greater than 0.09, okay? And in this case, Videra is completely correct because if I simplified 5/10, I would very easily, without having to convert or do anything, I should very easily be able to see that 5/10 is greater than 0.09 because 5/10, when I reduce it, I'm going to divide it, both of these by 5, I'm going to get 1/2. 1/2 is definitely bigger than 0.09, right? What's 1/2 as a decimal? How do I write 1/2 as a decimal?
0.5.
Exactly, right? So in this case, reducing would have definitely helped, right? Because I can see 1/2 being so much bigger than 0.09. I don't have to do a lot to figure this one out. All right. But when we are comparing fractions, that's why I wanted to do fractions here. I wanted to remind you guys of how to do this. When I'm comparing two fractions, I cross multiply bottom to top. Okay. Always, always bottom to top. All right. All right, let's keep moving. All right, so that was the last example of that. We're just gonna go over a couple more things, including looking at these negative numbers, right? So it's gonna be the same process, but the order changes a little bit when we're talking about negative numbers, okay? So remember that when we are ordering negative numbers, the smallest number is the number that is furthest or
Furthest from-
most furthest, sorry?
From 0?
Yep, from 0. Okay, so more to the left or furthest from 0, right? Whenever that number is really, really far to the left, it is smaller than the number that is closer to 0, okay? And we have to remember that because that's very different than when we're thinking about on the positive side. On the positive side, the further away from 0 you are, the bigger you are, right? But on the negative side, the further away from 0 you are, the smaller you are, okay? So it seems common sense now, but trust me, when you're looking at it on a piece of paper, sometimes that confusion will come back and you're like, oh, wait, why did I do that, right? So remember that as you get further away from 0 towards the left, you become smaller, okay, in negative numbers. All right, so we have negative 0.2 and negative 4/5. We're going to compare these rational numbers, but remember to compare these rational numbers, I need to either make them both decimals or both fractions. So what are we going to do here? Both decimals or both fractions? Again, it doesn't matter.
Both fractions.
Both fractions? Okay. So what's the name of this decimal? What location is this 2 in? What place? What decimal place?
Tenths.
In the tenth place.
So then it says negative 2 tenths.
Mhm.
So that's how I make it into a fraction, negative 2 over 10. So now it's a fraction. And I'm going to compare it to my negative 4/5. Okay. I'm still going to do the same thing. I'm going to cross multiply here. But what is the
So-
cross multiplication going to tell me this time? So what's 10 times 4 or 10 times negative 4?
It'd be negative 40.
Negative 40.
Okay, great. What's 5 times negative 2?
Negative 10.
Negative 10. All right, perfect. So which fraction is the bigger fraction? Is the fraction that is,
Furthest from 0.
okay, yeah, so there we go. Which fraction is furthest from 0? That's the best way to say it. Good,
Negative 40.
good. Negative 40 is furthest from 0. That means this fraction is smaller. So negative 0.2 is greater than negative 4/5. All right. Now, we're going to demonstrate that by putting these points on the number line down here that we have. So we have 0, negative 0.5, and negative 1. So that means every one of these blue marks is represented, it represents a tenth, right? So this is negative 1/10, so this has to be negative 2/10 or negative 0.2. Okay. And 4/5, right? In order to get it onto this number line, I need to change that into a decimal. So I'm going to do 5 into 4. But 5 can't go into 4, so I have to do 5 into 40. How many times does 5 go into 40?
8.
8 times. So this is
Now-
negative 0.8. So I have negative 0.5, negative 0.6, negative 0.7, negative 0.8 would be right here. So this is my negative 4/5. Okay, so I'm now able to see on a number line that -4/5 is further to the left than -0.2. Questions, comments, complaints? Okay. All right, we're going to do the same thing, but now we have a few more numbers to work with, right? Now we have 4 numbers, not including 0, that we need to graph on this number line and compare. Well, I think the easiest one, obviously, let's just get 0 out of the way, right? We know where 0 is. I'm just going to put it on there. 0 is good. 0 is taken care of. But now we have -1 2/5. We have -2.3. We have 3/4, and we have -1 9/10. Okay. Which number is which is the next one that's going to be the easiest to put on this graph of these 4 that we have left?
-2.3,
Why?
because it's already in decimal form.
Okay, it's already in decimal, and it's the only one that starts with 2, right? So we already
Right.
know that it's going to be the smallest one, right? And it's -2.3. We can probably figure that out pretty easily. So it's -2. So we know it's going to be somewhere in between -2 and -3, right? What do each one of these marks in between the 2 and 3 represent? How many, or what decimal places are we represented here? We have 1, 2, 3, 4 marks in between 2 and 3. So what are we counting by here?
Tenths.
Tenths? So that'd be 10, 10s, 20, 30, 40.
Oh no.
10. What are we counting by?
It should be ones then. I mean,
What are we counting by? When we have a space between a whole number and another whole number and it's 4 places, what do we count by? How do we get
Fives.
from
halves.
how do we get from $1 to $2 if we count only 4 times?
Oh, 25?
Ah. So this is -2.25, -2.5, -2.75, -3, right? Yes?
Yes.
Okay, so this is 2 1/4 or 2.25, and this is 2.5. So -2.3 is going to come right about here. So this is -2.3. And this is also my smallest number, -2.3. So it says I need to order it from least to greatest, and I know -2.3 is my smallest. That one is taken care of. Okay. What's going to be the next easiest one for me to take care of after that 2.3, that -2.3? I have -1 2/5, -1 9/10, I have 3/4. Which one is not like the others?
Oh, the 3/4?
Right, the 3/4. It's the only positive one, right? And it's the only one that has nothing to do with -1 right now. So it'll be easier to figure out how to plot 3/4, right? So 3/4 is positive, so I know it's going to be on this side of 0. It's also going to be the only one that's on this side of 0. So it has to be my biggest number. So 3/4 is going to be the greatest. And I already know that all of these dashes in between here represent a quarter, right? So how many quarters do I have? 3. So I just count 1, 2, 3, and this is where 3/4 is. So I have my negative 2.3 and I have my 3/4 already taken care of. Now, the hard part is these two, right? -1 2/5 and -1 9/10. So what I have to figure out now is which one of these is furthest from 0. So which one of these is smaller?
The 1 9/10.
So 9/10, that's almost 10/10. That's almost another 1, right? So it's going to be pretty close to -2. And this one is not going to be as close to -2 because it's 2/5. It's not almost a whole number, right? So definitely -1 9/10 is my next smallest number. And then after that, I'll have -1 2/5. Okay, so 1 9/10, I know, like I just said, it's almost 2, so I know where it goes on my number line. It probably goes right about here. You can say -1 9/10. But where do I put -1 2/5? Well, I should probably convert this 2/5 into a decimal to help me figure that out. So 5 can't go into 2, but how many times does 5 go into 20?
4.
Okay, so it's essentially -1.4. We know that I have -1.25, -1.5. So right before -1.5 is where I should put my -1 2/5. So this is my order from least to greatest: -2.3, -1 9/10, -1 2/5, 0, and 3/4. That's my order from least to greatest, smallest to biggest. So when dealing with something like this, it's always best to break it down into what's going to be easiest to deal with first. Leave the things that are closer together for the last so that you can figure it out there. I think a lot of people just like get overwhelmed. They see too many numbers, like I can't do it. But you can definitely break it down. You know, the 0, we know where that goes. The -2.3, we can figure out where that goes because it's the only one that's dealing with a -2. The 3/4 we can also figure out because it's the only positive. So then all we're really comparing at the end are the ones that are closer in number, are the 2 that are dealing with -1. So break these problems down into smaller pieces whenever possible.
So just to make sure I got it right. So -1 2/5, when it's written as a decimal, will be 1.4.
-1.4 right here. Yep.
Okay, all right.
Yes, because 2/5 as a decimal is 0.4.
Okay.
All right, one last page of notes. And then we are going to move on. Okay, so page 8. We're doing the exact same thing, right? We just did. We had a little preview, but it says to put the numbers below in ascending order. What does ascending mean? Or ascending? You can pronounce it either way. Ascending or ascending. What does that mean? What does it
The
mean?
highest at the top?
The highest at the top. So to ascend means to go up. Okay,
Go
so
up,
we are
okay.
going up in order. Ascend means to go up, right? So we are ascending, we're going up. So ascending is from the least to the greatest. or smallest to biggest. All right. So we have to figure out which of these numbers is the smallest and which of these numbers is the biggest. In order to do that, we know that we're going to have to convert these fractions into decimals to match the numbers that are already decimals. Okay, so 5/8 is the first one that we need to convert. We're going to need to convert 5/8 into a decimal. That means I need to divide the 5 by the 8, right? 5 divided by 8. Who can walk us through that? What do I need to do?
You can put five, you have to put a 0 first and the
To
decimal.
put a 0 first?
No, you have to put a decimal. Yeah, decimal.
Decimal first, okay?
Yeah.
Then what?
And then you put another 0 in.
Okay. And now I can divide 50 by 8.
8 times 6.
How many
And then
times?
8 times 6.
6, okay.
It could be 48.
Very good.
You go for you. So it'll be 10 minus 8 will be, and then it'll be 2. Then you cross that out, make it 4. Then it'll be 0.
Okay.
And then
I have 2 left.
but
And
then
now
sometimes
what?
you can go to another 0.
Okay, now I have to put another 0. Oh man. Okay. Now what?
You put another 0, then it'll be 20. But then you
Okay, I gotta drop down my 0 to make it
do
20.
that.
You're cutting out. You're cutting out,
And then you
Marvin.
put 8 times. It'll be 2 times, like 8 times.
Okay. Okay.
Yeah.
8 times 2 gives me what?
Come up. Give you 16.
Okay. What's 20 minus 16?
Like 10 times, for example, 10 times 6 it'll be 4. And then
Okay.
you cross that out, it'll be 1.
Okay, good. Yeah.
1 to
So now what do I do? I have this 4 left. What do I do now?
Okay, and then you have to, but basically sometimes you may have to keep going. Basically, I have to keep going
Okay, let's keep
until I
going.
get to 40. And do go,
Okay, so I
yeah,
have to
get 40.
put
Add another 0.
0 and get 40. Okay.
Yep.
Now what?
And then it'll be 5 times, because 8 times,
Oh,
8 times 5 is 40.
okay,
40. So
great.
40 in there.
Okay.
40 in
But
there.
this was a long one. That's why I didn't want to do it. I wanted somebody else to do it. So it is 0.625. So negative 5/8 is equivalent to negative 2.625.
Okay, now.
All right, so make sure you guys put that in on your note sheet. And now we have to convert 7/20. All right, who's gonna do this one for me? Who's gonna convert 7/20? Put it in the chat.
It's 20 divided by 7.0.
Okay, good. Uh, 7.0 divided by 20, but yes. Okay. How many times is
And
70 divided by 20?
3.03.
3 times. Okay,
0.03. Yeah.
0.3, okay. So what's 3 times 20?
6.
60, right? Okay. So I have 10 left. Now what do I do?
Add a 0.
Great. Bring that down. And now I have 20 into 100. How many times does 20 go into 100?
5.
5 times. All right, so that's 100. Now I'm done. So I have 2.35. So now I've converted everything into decimals. So now I have all decimals, right? And that should help me put them in order. So which of these numbers up here is the smallest? Which of these numbers is the smallest?
A 1.74?
Negative
No,
1.74?
no, 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 wait a minute.
No, no, no,
Oh,
no. Okay. Oh, right.
No, that's right. Negative 1 point, no, you said the smallest?
The smallest. Which one
I
is
would say it's the 2.4.
negative 2.4 is the smallest? But it's
Smallest. Oh, wait.
No, no,
Hold on.
negative 2.7.
negative 2.7. Is that the smallest? Negative 2.7?
Yeah,
Yes? Everybody agree?
Oh,
No, I think it's the negative 2.625.
Negative 2.625. Okay. Let's see. So we have negative 2.7 and negative 2.625. When we compare them, we're going to compare place value to place value, right? So we have 2 and 2, those are the same. And then we have 7 and 6. Okay, which one is bigger, 7 or 6?
7.
7 is
7.
bigger.
Point,
That
big
means
negative
that
2 point,
this number
negative
is
2 points.
smaller, right? Because it's negative. So negative 2.7
Oh,
is smaller than negative 2.625.
yeah.
Okay, so that means what's next? It has to be like Videra said, if it's negative 2.625, that would be next, right? So negative 2 and 5/8 is next. Now what? So we figured out this one, we got this one. All right, which one's next in our smallest numbers? Which one is the next smallest?
The negative 1.74.
Negative 1.74, perfect. All right, so we're done with all the negatives. Now we have two positive numbers left. We have 2.35 and 2.4. Which one is smaller?
2.35,
Why?
because the 3 is smaller than the 4.
Okay, all right. You convinced me. I wasn't sure, but okay. Yes, so this is my order. Again, remember that when we are comparing numbers, we have to compare the place values. So if we compare 7 to 6, when we're dealing with negatives, if that number is bigger, it is further to the left, it is smaller. So negative 2.7, negative 2 and 5/8, excuse me, I should have written here, not 2.35, but 2 and 7/20. So let's use the original number. And then 2.4 is the biggest. So when we
So I
ascend,
actually
we
wanna
go
have
from
questions
small to
on-
big. All right, we're ascending. There was a question. Somebody asked a question.
Yeah, so when we're taking the GED or the NDP,
Yep.
they're actually gonna have numbers like this where we're gonna have to compare and see which, there's gonna be fractions and decimals mixed? Oh,
Yes,
God.
ma'am. I'm not doing this for fun. I don't like this. This isn't just like, oh, let's have a good time today. And no.
That's why it's gonna take so long to take this test by the time we compare all these numbers.
So, I mean, you're probably going to only have like one, maybe two questions like this, but you have to be prepared if you see it, right?
Okay.
So yes, so on the CASAS test, this is something you need to be able to do, is to be able to compare numbers. Yes. Y'all think I'm out here just like, oh, let's compare numbers. That'd be a fun thing to do today. No, all of these things are skills directly from both the CASAS test or the GED. Okay, all right. So that's your order. We have another example where we're doing a similar activity. All right, so let's do that. So now we have to put the numbers in descending order. What's descending?
Least,
Mean to
mean,
descend.
down.
Mean from the greatest to the least.
Good. So we're going down, right? We're descending. Very good. Greatest to least. I love it. Thank you, Marvin. From greatest to least. So biggest to smallest. All right. So before we do all of that, of course, we're going to do the same thing we just did before. We have to convert these fractions to decimals so that we have all decimals to work with. So we have 1/3. I need to turn 1/3 into a decimal. Who's going to do that for me?
I was gonna say you try and put 1/3. 1/3.
Yeah, so it's 1/3. I know it's 1/3, so I have to divide it. So what do I do to divide it? I do 3 into
1.
1.
You can't do that with 1. You have to put a decimal. Decimal.
Good.
You put 10. You put no 0 in there. It'll be.
Okay.
You get that. You get 9.
Okay,
Oh,
so I
get
3 times what gives me 9?
9. Three times.
Okay, great. So 3 times 3 gives me 9. And now what do I have left?
Unlike that, like you don't got one. You only got
Okay.
1.
Okay, so what's happening here?
You had to add another. You had to add another 0. Add another 0 again.
Okay, so what's happening? What's going to keep happening?
It's gonna keep going to 3. Keep going to 3.
Oh, it's going to be 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3.
Yeah. So basically, it's a long one.
Okay, so I can just make it 0.33 because it's just going to be a bunch of 3s that I keep repeating, right? So 1/3 is just 0.3333333333 wherever. Okay, so we're just going to do negative 32.33. Okay, all right. So now we have 3/20. I also have to convert that one. 3/20. So again, that's going to be 20 into 3, which I can't do. So I have to add a 0. How many times is 20 going to 30?
1.
1 time. Very good. 20 goes into 30 1 time. I have 10 left. I have to add another 0, bring that down. How many times is 20 going to 100?
5.
It goes in 5 times, which gives me exactly 100, so I'm done. It is 0.15.
I have a question, Mr. G, about the negative 32.33, and it keeps going on and on. Do we
Huh?
put that line over top of it, that infinity line over the 3?
Sure, you can definitely do that. Absolutely. In
Oh.
this, yeah. So what you can do that, right? You can leave it as just a 3. It's not going to matter much, but yes, if you do see that infinity line, that's what that would mean. Is that it's a 3 that keeps repeating? But yes, you can do that. It's not going to make a difference in our calculations today, so that's why you don't need it.
Okay.
All right, so now we have all of our decimals, and now we can compare these numbers. All of these numbers are negative. So which one is our biggest number? That means which one is closest to 0? This is a tricky one. They gave you all close numbers. They're so close together. They're right on top of each other. I'm glad I don't have to do it. I'm going to sit back and relax. So which one is the biggest? Bless you, whoever sneezed. Which one is the biggest one? Which one is closest to 0?
The negative 32.33.
Negative 32.33 is the biggest.
Oh, no.
Okay, it's not the biggest. Okay.
The negative 32.2. No. Yeah.
Yeah. This one.
Yeah, that's the one.
This
Yeah,
is the
that's the
one.
one.
This is the one that's
Yeah.
the biggest.
Yes.
Negative 32.2 is in fact the biggest. Yes. Which one is next? Which one is just a little bit smaller?
Negative 32.3.
Negative 32.3. That would make sense, right? 2 and then 3. Yes. So yeah, negative 32.3. Great. Which one is next?
I was gonna say like negative 33.25.
Nope, not that one.
The
We still have
negative
another
32, 1/3.
Right, we still have another 32, right? So that one needs to go first. So it's negative 32 and a third, right? Which is negative 32.33. So it's just a little bit more, a little bit smaller because it has another number after that 3. Okay, so that one's done. So now we can go into the 33. So which 33 comes next? Comes first? Which 33 is smaller?
The negative 33, 3 and 20. With the 3 over the 20.
And 3/20ths, because it's negative 33.15, right? Which is small, which is bigger than 2/5. Good. And then that last one would be negative 33.
And then so basically yeah.
Mhm.
Yeah.
Okay,
I think I
so
might have said it in the wrong.
again, when we're dealing with negative numbers, this is where the confusion always comes, right? When we're dealing with negative numbers, we have to be very, very careful because this number, 0.2, is bigger than this number, 0.3, right? We have to reverse our thinking, and that is very, very difficult for us. So it's important that we do that practice of that ordering and make sure we understand how that ordering is working with our negatives and our positives, or sub-positives. Okay, when we descend, we're going from the biggest to the smallest. We're coming down the mountain. And we're literally coming down the mountain as far as our notes go. We're almost done. We have 2 examples and we are down that mountain. All right, here we go. Last 2. So it says Brenda correctly ordered the positive rational numbers below. Okay, so they are in the correct order as positive numbers: 5.3, 5 and 5/8, 6.74, 6 and 15/20th, and 6.8, right? They are least to greatest. They are in order from the least to the greatest, right? If Brenda is given the opposite of each number, how does she order them from least to greatest? So now they're negatives. So now how does she put them in order from the least to the greatest?
Negative 6.8.
Is going to be the least. Why?
Because it's the highest as a positive number. Oh, it's the
Right.
furthest away from the 0.
Very good, right? So if we're looking at the numbers and we know that 5.3 to 6.8, 6.8 gets further away from 0, right? It's going to be the exact same thing when we flip it and make it negative, right? It's just that 6.8 is now going to be your smallest number. Okay, so 6.8 is furthest from 0. What is going on with this thing? Sorry, it's the furthest from 0. So that means to put it in order from least to greatest, you just have to reverse it, right? So it's going to be negative 6.8, negative 6 and 15/20, etc., etc., etc. All right, so the order from least to greatest when they're positive is going to be the exact opposite least to greatest when they are negative. Okay. Last one. Brian and Sarah are discussing how to compare the fractions negative 5/6 and negative 2/7. Brian says that negative 2/7 is smaller because negative 2/7 is less than half and negative 5/6 is more than half. Sarah says negative 5/6 is smaller because it's closer to negative 1. Which student is correct and why? What do we think? How do we know who's right?
Negative 2.7 is the smaller one.
Negative 2/7 or negative 5/6? How do you know it's smaller?
Because you do the compare.
Okay,
You compare the fractions.
all right. So let's compare them. Let's see.
Because I was thinking you're gonna try cross over multiplying, like if that one, you say 6 times 2 will be times 2 is 12.
Negative 12, right?
Or negative 12.
And 7
yeah.
times negative 5?
And then negative 35.
Uh-huh. So tell me again which one is smaller?
So negative 5 over 6 is right. Cause see, when she said the smaller because it's nearly closer to 1. Closer to negative 1.
Okay, right. So Sarah says negative 5/6 is smaller because it's closer to negative 1, right? Remember, how do we decide which number is smaller when we're dealing with negative numbers? The further away from 0 it is, the smaller it is, right? So Sarah's explanation here, Sarah says that negative 5/6 is smaller because it's closer to negative 1. That's actually what makes her correct, right? So Sarah is correct, right? And if we do the comparison up here, we can see why she's correct. But also remember that when we are thinking about our negative numbers, if we're further away from 0, we are smaller. Right? So the further the number is from 0, the smaller the number is, okay? All right, y'all, so those are your notes for this week. always review your notes now that you have them. Your notes are, that's why we do them. We do them to make sure you have them and you have a reference material to go back to whenever you want to go back to them. That's why we have your notes, okay? The notes are important. They're an important step in making sure you learn things, because you want to do it together and you want to be able to go use it as a reference material. All right, so that being said, those are your notes. What I want us to make sure we look at so that we can know what needs to be turned in today. We're going to go into our week 4 folder again. All right, and what needs to be turned in today by 7. You have choice between doing practice number 2, where you're comparing rational numbers, or your exit ticket. I suggest doing practice number 2, honestly. So practice number 2, I'm going to open it in Kami so that you all see it. Okay, so practice number 2 is comparing and ordering fractions. And we know how to compare and order fractions, right? We're just going to do the cross multiplication to compare them. So make sure you guys are doing that to compare your fractions. And this needs to be in by 7 p.m. today, or you can do the exit ticket, but I suggest doing practice number 2 by 7 p.m. today to get the afternoon credit for today. All the other assignments, of course, are due by Friday, but you guys do have a full week off next week as well. So take your time to do them, but try to get everything done for this week in a timely manner before we have our next live class, which is not this Monday coming, but the Monday after. So that will be the 19th. On the 19th of October is when we will have our next live class. So you have all the time in between now and then to get the rest of the work done, but you need to turn in something, either practice number 2 or 3 by 7 p.m. today. It will also be a good idea to go ahead and upload your notes if they're complete, and just go ahead and submit them via Kami as well. And that's really all you have to do for this week. I do want to go over a couple of examples here of this compare and order fractions before I let you guys go, because I want to show you how to do more than 2. We haven't gotten a chance to do more than 2 yet, and I want to show you how to do an example where we're doing 4. So let's do this example here where we have to do 4 of them. I'm just going to do the one in the middle, because why start with the first one? The first one's probably going to be super easy. So let's do the one in the middle, and we're going to compare these fractions. So we have 3/4, 2/3, 3/5, and 7/8. Okay. So what I can do is compare each pair of fractions to each other, and that's going to help me decide how to compare the other pair. Okay, so I'm just going to compare this first pair and then compare the second pair. And then depending on which one is bigger, I'll compare those two, and that'll help me decide my order, right? So 4 times 2 gives me
8.
8. 3 times 3 gives me 9. So which one is bigger? 3/4.
3/4 done. Bigger.
Over here, 5 times 7 gives me 35. And 8 times 3 gives me 24. Which one is bigger? 7/8, right? Yes? No? Maybe? So because 7/8 is bigger and 3/4 is bigger, I can compare those two now, 3/4 and 7/8, decide which one is the biggest one. 2 times 4 is 28. 8 times 3 is 24. They're close, but 7/8 is bigger than 3/4. So I know my order so far is 7/8 and then 3/4. All right, and then I just compare the two smaller ones, 2/3 and 3/5. 3 times 3, 9. 2 times 5, 10. So next is 2/3. And finally, the last one is 3/5. All right. So you have one of your answers already done for this practice. And you have a good strategy moving forward for comparing your fractions. One of the other things to do is to try to see if you have some that are smaller than a half or bigger than a half, but all of these are bigger than a half. So you can't really do that comparison there, but 7/8, 3/4, 2/3, 3/5. That's the order for this one here in the middle, right? Oh, actually,
I
excuse me.
thought it was from least to greatest, Miss.
I
Yeah.
literally just was about to say, I put them in order from greatest to least. You need to actually put them in order from least to greatest. So it should be 3/5, 2/3, 3/4, and then 7/8. It's always a good idea to read instructions too. I'm just gonna put that out there as a general rule. Just always read instructions before you do anything. It saves you a lot of drama. So don't do it this way. Do it this way. So yes, comparing 4 is more work than comparing 2, but I believe in you guys. And I know you can do it. I truly believe in you. All right, so that is your homework assignment. And so now I can leave you guys with questions. What are the questions, comments, or concerns? We're 4 weeks in, well, 4 full math weeks in. This is actually like the 6th week of school or something like that. But we've only had 4 full weeks of math content. So what are our questions?
I have one, Mr. G.
Yes, ma'am.
Okay, so what I'm seeing from what I'm seeing, we can like any fraction can be cross multiplied
To compare it to another fraction?
to
Absolutely.
compare it. Yes.
Yeah. Mhm.
So it doesn't just necessarily have to be a negative fraction.
Correct. It doesn't have to be negative or positive. There's no requirement there. But you can cross multiply any fraction to compare them. You will notice in these examples, I've used some very big fractions. And so remember what the suggestion that you gave before about simplifying them or reducing them before you compare them. That might be a great idea here for some of these fractions that are really, really big. It might be a good idea to see if you can reduce them before you compare them so that you're not dealing with huge numbers. But if you're fine dealing with the bigger numbers, then you don't need to reduce them. But yes, any fraction can be compared to another fraction with cross multiplication.
All right.
Any other questions?
I have a question, but it doesn't relate to the math.
What?
You said, because I'm okay on the math so far.
Okay.
You
all
said
right,
we
go
don't
ahead.
have class next week. What? I think I may have missed something. How come we don't have class next week?
So next week is DCPS's fall break. And so we also have a break scheduled because it was supposed to coincide with DCPS's fall break. I don't know what the actual calendar is for DCPS right now because of everything that's been going on, but we kept our calendar the same. So we have a fall break next week, which means that there are no live classes next week. That does not mean that you guys can't still ask me questions if you have questions on your work. Like I'll be available for that, but we won't be having any live classes because we are supposed to be on a scheduled break for students next week.
Oh, okay, okay.
Yeah. So those of you who are, working towards your NADP program and all those things, I'm sure Ms. Dawn will still be available as regular, to check in with you, but we won't have any live classes. I won't be adding anything new to the Schoology page until next week, Friday, to prepare for the following week. All right, any other questions?
Yes, Mr. G, every time I try to go into my Schoology, it's tell me it's temporary unavailable.
Yeah, so I think it's going through some stuff today. So go ahead and take a mini break from it maybe, and then check back in like a half hour or so. I just think it's just a lot of people probably doing the same thing, all at the same time. So it's probably a little bit overwhelmed, but I think if you just refresh or wait and come back, it should be okay. It's just, it's having issues today. It's being temperamental. you know, it's having a little fit. It'll be okay.
Okay, that's not gonna affect me trying to turn in the work, is it?
It shouldn't, it should not. But if it does, like if you try to go in a little bit later today and you still can't get in, go ahead and send me a message, you know, via Remind or whatever to let me know that you still can't get in, and that I won't make it a requirement to turn anything in today.
Okay.
Okay. Any other concerns? All right, y'all. Enjoy your week off. Use it productively, right? Don't just like decide that you don't have to think with your math brain anymore because you don't have math class. So you know, use it productively, but do take the time to rest and relax. There's a lot of crazy things going on in this world. I feel like every day I wake up just like more and more concerned for the world, and I just have to be like, okay, no, need to refocus. I can't take care of the world. I can only take care of me. But so make sure you do take some time to care for yourselves during this break. And I will see you guys on the 19th, or I will see you on Friday if you have me for science class. Bye, guys.
Bye.
Mr. G.